Hi, I'm Chris, and in this video we're going to be covering how to create a 2D adventure game using Adventure Creator. So I'm starting here with a new Unity 6.1 project with the URP's 2D renderer installed, input system, and Adventure Creator imported from the package manager. So without further ado, let's get started. To begin working with Adventure Creator, we first go to the New Game wizard to set up our game's initial assets. We can do that from the top toolbar by choosing Adventure Creator, Getting Started, and then New Game Wizard. From the first page, I'll choose Begin and then New Game. And it's then a case of filling in all of the details that it asks for. So I'm going to name my game AC 2D Primer, choose Next, and we then get to choose our game's perspective. We can choose from 2D, 2.5D, or 3D. I'm going to choose 2D, and then we'll move on to movement. And here we've got either point and click or direct. I'm going to choose point and click, but none of these changes are commitments. We can change them at any time once our game has been made. Next, we'll choose our input. I'll go with the default mouse and keyboard. And the interaction style I'll leave as context sensitive, as it gives us just a regular one-click interface. On the next page, we can choose what templates we want to install. These are entirely optional, but they can help to get us up and running even more quickly. And you can see by default, we've got a 2D sample player, 2D sample scene, and input system integration already checked to install. Others we can either choose to install now or later by returning to the wizard. But I'll leave these unchecked, choose Next, and then we'll get a chance to review our choices. The one change I will make is that of our default interface. At the moment it's set to Adventure Creator, which is its built-in UI system, and I'll change it instead to Unity UI. Again, this isn't a permanent choice, and we can switch between the two modes at any time. Finally, I'll click on Create, and after a few moments, the wizard will finish preparing all the assets. I'll choose Don't Save the Open Scene, and then close the wizard. And you can see we now have our sample scene loaded in the hierarchy, as well as the AC game editor, which I'm going to dock over here on the right. And if we now enter play mode, we can test this all out and find that Adventure Creator runs all of this sample content straight out of the box. So here we have our sample player walking around the sample scene. I'm using point and click to move him around, and we can interact with some starter assets to demonstrate how all of these different aspects work. The AC game editor features 8 tabs up at the top, and each of these tabs represents a different manager or aspect of your game's development. For example, our settings manager here has all of our options related to the way that the game is generally played, such as the movement and input methods. The inventory manager is where we define all of our inventory items, and the menu manager is where we define our interface. Each of these managers are asset files, and you can see that the New Game wizard has created a folder for them inside a directory that has the same name as our game, as well as subfolders for each of the templates that we chose to install. And now that we've got something to work with, I'm going to go to File, New Scene, choose Basic URP, and create a new scene that we can build some of these assets back up from scratch. I'll start by going into 2D view and then dropping in a background sprite. I'll use the same background as the sample scene, and I happen to know it's called Room, so I'll type that into the project window and then drag the room sprite into the hierarchy. This is always going to be drawn behind the player, and the player's sprite is going to have an order in layer of 0, so I'll make sure that the background sprite has something less than that. So I'll just lower this order in layer to some negative number. When adding art to an Adventure Creator scene, It is worth bearing in mind that the default values for movement and physics and so on are all assuming that you're sticking with Unity's own unit system. That is, 1 unit is equal to 1 meter. So if we zoom in a bit, we can see the grid lines in our scene, and these roughly correspond to about a meter for the player when they're walking around the middle of the scene. If you find that a sprite is too big or too small, we can adjust it by going to the sprite's texture settings and then adjusting the pixels per unit value. As it is, this size is fine, so I'll come back out of there and go to the AC Game Editor and then choose the Scene tab. And right now it doesn't look like much, and that's because we haven't initialized our scene to use Adventure Creator. We can choose to set up our scene either with folders or without. If I choose with folders, you'll see that we have a bunch of helper objects that will be used automatically to organize objects that we later create. But I prefer to do it without folders, just so that we have as few game objects as we need in the scene. With that, we have the rest of our scene manager created, and in the hierarchy we have a game engine, a player start, and a main camera with Adventure Creator's main camera component. We don't need the directional light, so I'll remove that. And if we select our player start, you can see it's here represented by this blue arrow, and this marks where the player is going to be positioned and facing when the scene begins. And I'll position this over to the side by the doorway here, and then rotate it so that it's facing the middle of the room. And if we now enter play mode, you'll see that we have our player character standing by the doorway, and we have our interface, which lets us access inventory items at the top and the pause menu at the bottom. But there's a few things wrong with this, and we'll sort them in turn. And the first thing we'll do is fix the camera. Back in the Game Editor's Scene Manager, you can see we have a list of scene settings. This is where we have our default player start assigned, and just underneath we have a default camera field. This is left blank at the moment, but we can generate one just by clicking the plus icon beside it. It's created this new object called navcam1, and you can see it's positioned right in the middle of the scene. By default, this camera is stationary, it's not going to go anywhere, but if we go to the inspector and down at the bottom we find the game camera 2D component, we can uncheck lock in both the horizontal and vertical movement panels. The horizontal and vertical movement panels only affect the camera's X and Y position changes, and if we come out of 2D view, you can see that it's in the same plane as the background. So I'm just going to lower its Z position to something negative, and then when we play the scene, you can see that the camera is centered around the player's feet or his origin, and we can correct that by going down to the vertical movements offset field and just raising it a little bit, like 1.4. You can also see that the camera is spilling over the edge of the background sprite, and we want it to stay within the boundary of this background. To fix that, we can check the constrain option, and by default it will constrain to minimum and maximum values, but if we supply a background constraint, it'll make sure the camera does not leave that boundary. Our background is the room sprite, so if I drag that into the renderer field here, and you can see we're still in the middle of the scene, and that's because we're doing this all in play mode. So at the top of the game camera 2D component, I'll click on the top right menu and choose copy component, come out of play mode and choose paste component values. And if we then rerun the scene, you can see we now have our character more in the middle of the scene, but we aren't going over the edge of the background. We can't really do much more for the moment with our camera because it is set to follow the player, and yet the player is not able to move. So we'll sort that out next. If we return to the Scene Manager, you'll see we also have a default nav mesh field, and again we can click on plus to create one. If you're familiar with Unity's Polygon Collider, that's all this is. we can come back into 2D view and look at its inspector. You can see that we control the shape of this nav mesh with this polygon. So if I readjust my scene view, zoom in a little bit and click on Edit Collider, I can move these vertices around to just describe the shape of the room that we're in. And because our player start is within the boundary of this polygon, you'll see that we can move around the scene and the camera is following as well. If we move to the bottom of the scene, we can see I forgot to apply the background constraint to our camera's vertical position as well. So if we go back to our camera, we'll find the vertical movement panel, and I'll check constrain in that as well. When building a nav mesh, we might find that if we have a particularly complex scene that has many vertices that make up the polygon collider, you might find that we get a bit of slowdown each time a character begins moving. If that's the case, we can actually switch our pathfinding algorithm to a faster one, which we can find in the Scene Manager. Up at the top and above the nav mesh, we have this pathfinding method, which by default is set to polygon collider. But if we were to switch this to A** 2D, it'll rely on the A* algorithm, which is a lot faster for complex polygons. The main issue with our scene so far, though, is the fact that our character doesn't change his size as he moves around the scene, making it look like he's very big back here and very small when he gets down to the bottom. We can fix that by using a sorting map, which is a way of controlling how characters render differently according to their position in the scene. We can go back to our scene settings, and we have another field for our default sorting map. Click on the plus to create a new one, and if I then select it, you can see in its inspector we have a series of areas that we can add. To begin with, I'll move it to the topmost point of the nav mesh. It doesn't need to be entirely accurate, but just roughly around the highest that the player can go in the scene. Next, I'll add a new area, and you can see we now have a second gizmo in the scene that we can manipulate by dragging down. And this one I'm going to align with roughly the bottom of the nav mesh. You can see we have start scale and end scale values, and this controls how large characters are based on their Y position. So I'll reduce the start scale to about 67 and raise the end scale to a little bit bigger. And you can see that these visual indicators in the scene window cause the box to get wider at the bottom to indicate that. Finally, we'll have a look at the properties panel. And we want this to affect the character's size, so I'll check Affect Character Size. But I'm also going to uncheck Affect Character Sorting. And that's because Unity now allows this out of the box, so we don't need this legacy feature of the sorting map component. If we now play the scene, our player character now changes size as they move around, giving us a better illusion of depth. We can make this scene a bit more interesting to move around by having a large object that the player needs to navigate around. I'm going to make use of the tree sprite from the 2D demo, which is Park Tree, but really you can use any sprite that you like. I'll drop the sprite into the scene and move it around about here, maybe scale it down a little bit. And it's important to bear in mind that the sprite's pivot point, as in this origin here, needs to be around the base of the sprite as it appears on the floor of your scene. Now we're going to want our player character to appear behind this tree when he's above it, and on top of it when he's below. We want to use this pivot point as a reference for whether or not he should be drawn on top or underneath. So we'll set the sprite sort point from center to pivot. If our pivot point isn't where we want it for a given sprite, we can go back to that sprite asset and adjust the pivot point in its inspector. To have it so that sprites adjust their sorting order based on their Y position, we need to adjust Unity's transparency sort axis. If we're using the built-in render pipeline, we can do this from the Edit menu and then Project Settings, and under Graphics options, we'd have the options to do so here. As it is, I'm using URP and its 2D renderer, so if I select my 2D renderer from the renderer list and go to the General tab, we have a transparency sort mode. At the moment it's set to default, but if I set it to custom access and leave it as its default transparency sort axis of 0, 1, 0, then it means that sprites will be sorted based on their Y position. So if we now go into play mode, we have our tree in the scene, and if we move our character behind it, he'll appear underneath, and below it, he'll appear on top. However, at the moment, this tree is not a solid object, so if we click from the bottom to the top, he'll just go straight through it. To fix that, we can add a hole to our nav mesh, and we can do this with a separate polygon collider. So I'm going to go to Game Object, Create Empty, and I'll call this tree hole. I'll position it around the base of the tree and maybe parent it to our tree sprite as well. And then I'll choose Add Component and add the Polygon Collider 2D component. This isn't going to use collision, but rather adjust the nav mesh. So I'll check Is Trigger and then edit the collider so that it fits around the base of the tree. We then just need to carve this shape out of the nav mesh. So if we go back to our default nav mesh and underneath nav mesh holes, I'll click Create New Hole and then assign our tree hole as the polygon to carve out. Let's now start to make our scene interactive, and we'll start with this tree we have here in the middle. We can go to the Scene Manager, and at the bottom we have a Scene Prefabs section, and inside the Logic panel we have Hotspot 2D. And a hotspot is a portion of the scene that we can make clickable. If I click on it, we'll get a new hotspot represented by this yellow cube in the middle of the scene. And if we run the scene with gizmos enabled, you can see that whenever the cursor enters this hotspot, the hotspot name appears above it, and if we were to make any interactions for it, they would run when we click. We can have this hotspot be a part of the tree automatically by selecting the tree at the time we make it. I'll delete the one we just made and then click on the tree sprite. And if I click again on the hotspot 2D icon, it'll ask us if we want to convert this sprite into a hotspot. If I choose yes, this whole tree now becomes interactive. It's not represented by a yellow cube anymore. Instead, it's attached the polygon collider so that the clickable area matches the sprite. We also have a hotspot component. Because our interaction method is set to context sensitive, it means that we use a one-click interface, and we can left-click to run a use interaction and right-click to run an examine interaction. We can quickly create a pair of these by clicking the plus icons beside each of them, and we'll then get the properties of the interactions themselves. With the examine interaction, I'm going to have the player action set to turn to face, so that the player will face the tree before doing anything, and then what they do will be bound by the interaction. So if I click on the plus icon beside this field, we'll get a new game object called Park Tree Examine. And if I click on the node icon beside it, it'll bring up the action list editor, which will be the building block logic for this interaction. I can dock this into the same space as my game window. And you can see by default, this is just an engine wait action. So I can change this to, for example, a dialogue play speech action. If I check player line, the line text box will then be spoken by our player character. So I can just type in something like, that's a big tree for a room with no soil. We can test this out by walking up to the tree. You can see the name of the sprite is appearing in the hotspot label. We can fix that later. And if I right-click to run the use interaction, he'll turn to face and say the line text. The name of the sprite and game object is Park Tree. So if we want the hotspot label to be just tree, we can either rename the game object or set a label if not name field inside the hotspot component. For the use interaction, we'll do something a little bit more complex. We'll have the player walk up to the tree before doing anything. This time we'll set the player action to walk to. And this is a good idea if we have an object that is in the middle of our nav mesh, as in the player can approach it from multiple angles. I want the player to get quite close to it, so I'll check set minimum distance with a proximity of about 1.5. I'll click to create another interaction, and this one I'll just have again with some dialogue play speech where he says maybe no branches to climb. I think I'll also go back to our use interaction and check face after moving, just to make sure that our player still faces the base of the tree once he's arrived at it. We can also turn our attention to the exit over on the left here. And this exit here isn't its own sprite, so we'll just use the Scene Manager's regular way of adding hotspots. I'll go back to the logic panel and create a new hotspot. This one I'll name exit. If I drag it over to the exit here, and I'll just reshape this box to fit the visual portion of the scene that we want to affect. As before, I'll create a new use interaction, and this time I want the player to move to a specific spot in the scene rather than just approach it generally. So I'm going to set the player action to walk to marker, and it'll say a walk to marker must be assigned above for this option to work. We have a walk to marker field up above in the properties box, and I can click on the plus icon to create that. This is represented by a green arrow this time, and it'll appear in the center of the hotspot. I'll move it down to just inside the edge of our nav mesh, maybe tilt it a little bit towards the upper left here. And then going back to our exit hotspot, I can create a new interaction, open it up, and if we were making a game with multiple scenes, what we could do is run the scene switch action to change the scene referencing either its build index number or its file name. And so long as the other scene is referenced in our build settings, then it'll then switch to that scene. Build settings can be found from Files, Build Profiles, and then clicking on Scene List to bring up the list of scenes that our game features. Since we're not working with any other scenes, I'll just end the game instead, but I'll first have the camera fade out to give it a little bit of a transition. If I go to camera and then fade, we'll create this camera fade action, and I can set the type to fade out. And before we do anything else, I want this action to complete in full, so I'll check wait until finish. I can click on the socket down here and drag out a new wire, release to then create a new action. So this new action will be run afterwards, and this is going to be an engine end game with the command quit game. If we run this again and maybe move our player character a little bit further away, you can notice that if we click on the exit, we can also click away while our character is moving there. And that's the advantage of assigning a walk to marker inside our hotspot. If we didn't want to have this behavior, we can check cutscene while moving so that the player can't escape this sequence once it's begun. If you tried using this exit in the 2D sample scene, you might remember that the player character actually walks through this door, so let's recreate that functionality here. We can create a new marker around about here that we can have the player move to before ending the game. So if I go back to our scene manager, this will be a separate marker to our hotspot's walk to marker. So if I go to the scene manager's navigation section, I can click on marker 2D to create a new green arrow that I'm going to position just about here. If you imagine a line between our hotspot's walk to marker and the exit. In fact, I'll move it a little bit further down and then move the walk to marker a little to the right. Returning now to our exit interaction, I want to have the player character move towards this marker before running these actions we've already made. So I'm going to right click in some empty space, choose add new action, and this one is going to be a character move to point. We're going to be moving the player, so I'll check is player. The marker to reach is going to be the marker 2D we've just made. In fact, I'll rename this to exit inside marker. And we have an option to pathfind, which is normally what we want, but in this case, the marker is actually outside the boundary of the nav mesh. We won't need pathfinding because we're going to be just going from a straight line between these two arrows. So I can uncheck pathfind, but I will check wait until finish. I want this action to be the new start of this action list, and I can do that by clicking on the cog icon and choosing move to front. Our actions are now starting to overlap now, but we can fix this very quickly by clicking the auto arrange button. So now we have our character move to point, our fade out, and then end the game. You can see that the character, though, is still visible when moving to this marker, and that's because this background sprite is just one big image. It doesn't have a separation between this wall and the inside of the exit. We do have a sprite for this, however, and if I go to my project window and type in doorway mask, we have a sprite we can take from the sample scene and just drag it into the hierarchy. You can see that this is just a section of the wall that we want to obscure our character. So I'll move it to around about here. In fact, if I turn off gizmos, I can just see a little bit better. As with the tree sprite we made, we want this to be drawn underneath the player character when he's below it in the y-axis, and we want it to be drawn on top of the player character when the player is above vertically. So again, we've got our pivot point, our origin of the sprite around the cutoff point on the y-axis. And so all we need to do is make sure that the order in layer is 0, which is the same as our player character, and that the sprite sort point is set to pivot rather than the center of the sprite. And so now if we run the scene and just move here, we can see that we're not obscured by this mask sprite. But if I click on the exit and go through, the player will be hidden by the mask. We can have a similar sequence for our opening cutscene and just have our character begin in the doorway here and move out towards the player start. We can create an opening cutscene by going to the Scene Manager once more, and underneath the Scene Cutscenes panel, we can click on the plus icon beside On Start. We could have our character begin in the doorway by moving the player start inside here, but it's a good idea to have the player start be within the confines of the nav mesh, just so that if we deleted the On Start cutscene, the game will still work. We can open up the actions for this cutscene also by clicking on the node icon in its hierarchy. And to begin with, we'll have the camera be fully black by default. We could do this with a camera fade action. I'll set the type to fade out and check instant. Next, we'll have the player teleport to this position. So we'll run an object teleport action. We'll check is player and set teleport to the exit inside marker. Next, we'll fade the camera back in with another camera fade action. I'll leave these as the default fade in values. And then, similar to our exit interaction, we'll run a character move to point action where we affect the player, and the marker to reach we'll have as the player start. And I'll also check wait until finish and uncheck path find. As we start to build up our game and create more cutscenes, it might be helpful to be able to skip them as we're playtesting, and also allow players the option to skip them as well. We can do this by creating an input named End Cutscene, and we can get a list of all inputs that we can create by going to the Settings Manager and going down to the Input panel, and there you can see a list of valid inputs based on our settings. End Cutscene is a button that we will define based on our input handling. If we were using Unity's old Input Manager, this would be a case of going to our project settings, going to Input Manager, and creating a new input here. But as it is, we're using Unity 6.1, which uses input system by default, and so we're making use of AC's integration for that. Inside the game folder that the New Game Wizard created for us, that means we have an input system subfolder, and inside that we have a controls asset that we can double click to bring up the inputs. We have a few of these inputs defined for us already, and one of them here is End Cutscene. And you can see by default it's set to escape, and this is also the same button that opens up the pause menu. So I'm going to make it a separate button by clicking on the path and making it the tab key. And it is a very brief cutscene, but if I press tab while it's playing, you'll see that the cutscene ends and we end on the last frame of what would happen if we ran it normally. This is, of course, a very simple cutscene. We can also rely on Unity's own cutscene system in the form of timeline. We have an engine control timeline action, and this lets us control playback of a timeline asset. AC has a number of custom timeline tracks, which I can show off very quickly just by right-clicking in our project to create a new timeline asset. And if I click on the Add New Track button, you can see we've got custom timeline tracks for playing character speech, affecting the camera, as well as animating characters automatically based on their change in position. Timeline is a very complex tool though, and so there is a dedicated tutorial for it on the main Adventure Creator website. A core part of many adventure games is its inventory system, as in the items that the player can pick up and use around the game world. In this scene, we'll add maybe a worm that we can put on the floor here, And to test out interactions, we'll have it so that we can put the worm on the tree here. We have a worm sprite that we can get from the 2D demo. If we type in worm into the project, we have a worm icon. This is the icon that we'll see in the inventory, and a couple of sprites for when the worm is actually in the scene. I'll drag one of those into our hierarchy here and put him down on the floor. As we'll have another worm a little later on, I'm going to just rename this sprite to worm_ground. To make this worm interactive, we can again go to the scene manager and create a new hotspot. I'll choose yes to automatically create it. And again, it's added a polygon collider to describe the clickable portion of the scene. Because the worm is so small, I'm going to remove this and replace instead with maybe a circle collider, just to make it a little bit easier to click. I don't want this to affect any collision, so I'll check is trigger as well. In the hotspots panel, I'll set the label if not name to worm, and I'll create a new use interaction where we'll have the player walk to a marker. I'll define that marker by placing it around about here. Later on, we'll play some animations, so we'll want the player to be in a specific spot. I'll also check face after moving, and then the plus icon to create that interaction. And the first thing we're going to do is hide this sprite from our scene. We can do this with an object visibility action, and we'll affect worm ground and set the visibility to invisible. To place the worm in our inventory, we can use an inventory add or remove action, but you can see that right now no inventory items exist. We can fix this by going to our inventory manager. Back up in the AC game editor, I'll click the inventory tab, and then under the items sub-tab, I can click create new item. I'll name this worm, and I'll give it the main graphic worm icon. If we wanted the player to be carrying this by default, we could check carry on start, and underneath are more options for how many the player can carry. You can see that our interaction has now been updated, and by default it's set up to add the first item we've defined. So it's going to add the worm to our inventory. We'll also want to make this hotspot non-interactive so that we can't click on it again. And we can do that with a hotspot enable or disable action. And set the hotspot to affect to worm ground and set the change to make to disable. Since we're both disabling the hotspot and making this worm invisible, we can also deal with this situation either by teleporting this worm game object to a marker that's off screen, or by just removing the object from the scene. And in fact, I'll do that instead. I'll set this last action instead to an object add or remove action, where we'll use the remove method to delete this worm ground game object. Since this worm is being removed from the scene, we now don't need the object visibility, so I can delete that. Again, clicking auto arrange to bring up our two actions in line. If we run the scene now and click on this worm, we can then find it in our inventory bar, which by default is accessed at the top of the screen when we mouse over it. If we click, we can then select this worm, and clicking again on another object will allow us to combine the two. Similar to hotspots, we can also examine the worm by right-clicking, and we can define such an interaction within the inventory manager. Inside standard interactions, we can define an examine action list. I'll just go to my AC2D primer folder, click on plus, and it's created this worm examine. I can bring up the actions for it by double-clicking this asset, and I'll just set this to a simple dialogue place speech. If we want to have reactions when using the item on other inventory items that we might create, we can do so within the Combine Interactions panel. But in this case, we want to use the worm on this tree here. If we click back on this tree hotspot and go down towards the bottom of its inspector, we have an Inventory Interactions panel. I'll click on the plus icon to create a new one, and you can see the next field that appears is the inventory item that this is going to run for. We only have one item, so it's showing worm by default, and since we're going to have the worm in a specific spot, and later on we'll have our player play a specific animation, I'm going to want the player to run this interaction from a specific position. So for that, I'll set the player action to walk to marker, and define that marker up in the hotspot, and I'll put it just to the lower left of the tree here, maybe rotating it to the upright. Going back to our tree, I'll check face after moving and define a new interaction. Inside this interaction action list, the first thing I'm going to do is use an inventory add or remove action to remove the worm. And next we're going to add a sprite to our tree. Rather than spawning in a worm at runtime, I'm going to have the sprite in the scene itself, just invisible by default. I'll grab another worm sprite from the project window and drag it over so that it's on the tree. Now you can see that this worm is now not visible because it's hidden behind the tree sprite. We can solve that by setting the order in layer to 1, but we'll have a problem with our player character that we can show off by running the scene. If we just move below the tree like this, you can see that the worm is always being drawn on top of our player character, and that's because our player sprite has an order in layer of 0. To fix this, we can just parent the worm, which I'll rename to worm tree. We can parent this to our tree hotspot, click on the tree itself, and then add the component sorting group. And what this does is it combines all of the sprites in its hierarchy, causing them to act as though they have an order in layer in relation to other sprites, but the worm will still be above the tree. We're going to want this worm to be invisible by default, and one way to do this is to uncheck the sprite renderer component, but this makes it a little difficult to return to if I want to make changes while I'm working. So instead, I'm going to add Adventure Creators Remember Visibility component. Remember components are to do with Adventure Creators' save system, and it allows specific objects to have their data saved. We'll go into this more properly a little later, but all we need to see right now is that it has a visibility on start option, which I can set to off to have it invisible when the game begins. Returning to our tree worm interaction, we can now make this new worm sprite visible with an object visibility action. The object to affect will be our worm tree, and we'll set the visibility to visible. Now that we have a couple of interactions in our scene, we can add some polish by giving our player character some animation when we run them. Our player character is the sample 2D player prefab, and you can see we've got a subfolder, sample 2D player, in which we've got a player character and an animator controller. This was created by the New Game Wizard and gets spawned at runtime because it's assigned as our default player in the Settings Manager. Inside the animator controller, we have all of their animation states, but rather than edit this, I'll go and create a new one from scratch to cover the creation process. We don't have to do this, but just to keep things tidy, I'm going to delete the sample 2D player subfolder. And you can see we now have no player in our settings manager. To start creating a new player, we first need a sprite in the scene to act as the base. I'm going to be using the 2D Demos player character, which uses the same sprites but has some additional animations. I can find these inside the Adventure Creator folder, then choosing 2D Demo, Graphics, Sprites, Brain, and then Brain Idle. I'll drag in the idle_d sprite, and you can see we've got our player character looking the same as he did before. To convert this sprite into a player, we can use Adventure Creator's Character Wizard, which we can get to by choosing Adventure Creator, Editors, Character Wizard. Our character type is going to be player. Our base graphic is going to be this idle sprite, bearing in mind that it needs a game object of the sprite rather than the sprite asset itself. Our character's name is going to be my new player. And in the configuration panel, we can choose an animation engine. And for 2D, we have a choice between Sprites Unity and Sprites Unity Complex. And this affects how we control animation playback. Sprites Unity works by naming convention, meaning animations will be played automatically based on their name, while Sprites Unity Complex plays animations according to animator parameters that we can configure in their inspector. For this, I'll choose Sprites Unity, and we also have the option to automatically add animator states, and because we have no physics involved, I'll uncheck Add Collision. If I now choose Create, we can see we've got my new player in the hierarchy. And if I go to their inspector, you can see we now have Adventure Creator's player controller, as well as some additional components. Up at the top, we have a standard 2D animations panel that lets us configure their idle, walk, run, and talk names. And these will be played automatically based on what the character is doing. And if we expand this, we've got their sprite as a child object, and they have an animator controller that Adventure Creator has made. I'll create a new folder to place all this in, called Player, and I'll drag in both the controller and I'll make a prefab out of this new game object. We can also make this player prefab our default by going back to our settings manager and assigning it in the player prefab field. This prefab will be spawned in automatically whenever a player is not within the scene file itself, so we can remove this and have our player be spawned in at runtime. You can see right now, though, that the animations are no longer playing. And if we go back to our animator, you can see we have animation states for idle, walk, and talk in each of the 4 ordinal directions. So _D for down, _U for up, L and R for left and right. If we wanted to add diagonal animations as well, we could do that back in the player component, and we can check facing directions from 4 to 8. And if we check List Expected Animations, we'll then get a list of all of the animations that we're going to need in our controller based on the above settings. If we select any of these animation states, you can see that the motion field is actually empty, so we'll need to assign them manually. We already have some animations from the 2D demo, so we can go back to 2D demo, animations, brain, and then we have this demo character's standard animations. So for idle_D, I'll drag in brain idle_D, do the same thing for up, left, and right. And we'll have to do the same for walk and talk as well. Backing out of prefab mode, let's try the scene again. And we now have our player moving around. He's moving a little bit slow, and you can see that the worm sprite is also displaying on top of him again. So let's see if we can fix that. I'll go back to our games subfolder and then find the player prefab. Going back to our idle sprite, I'll make sure that our sprite sort point is set to pivot, as in the base around his feet. We can make him walk a little bit faster by adjusting his walk speed scale, maybe to 2.5. And for maybe a more natural looking motion, I'll check turn before pathfinding. So now that we have a player character of our own, let's add a few new animations that we can play as part of these interactions. For example, when we pick up the worm here, we want to play a picking up animation. We've got some animations that we can use back in our 2D demo animations brain folder. And you can see we've got brain take ground _dr, which stands for down right. I'll find an empty space in our animator and drag and drop this new state, as well as take a note of the name by copying it. We also have an animation for taking something at mid height called brain take mid _ur, so I'll drop that in as well. These animations are all created using Unity's built-in animation system, so refer to Unity's documentations if you're not familiar with how to create animations in Unity. Back in our worm use interaction, which will be run when we pick up the worm, we can add a new action by right-clicking in some empty space. I'll choose Add New Action, and this will be a character animate. I'll check Is Player. The method is that we're going to play a custom animation, and the name of that clip is going to be brain take ground _dr. I'll check wait until finish and then ensure that return to idle after is also checked, and reroute the first action so that this runs before we remove the object. If we now click on the worm, we get this custom animation play. Although the worm, and I'll play this again, the worm is only disappearing once the animation has completed in full. Let's see if we can make it so that the worm disappears halfway through the animation to make it look a bit more natural. We could uncheck wait until finish, but that would mean we have to have another action at the end of this chain in which we reset the player back to idle. So instead what I'll do is I'll disconnect the character animate action from the object add or remove, and instead we'll have two actions run at the same time. So I'll move both of these down and add a new action. This one is going to be an action list run in parallel. We're going to have two outputs. This will run from our inventory add or remove. The first of these chains is going to be our character animate. And to the second chain, we'll have our object add or remove that removes the worm. But in between these two, we'll have a little bit of a pause so that it doesn't run immediately. We can do this with a simple engine wait action. Let's say maybe half a second. And I'll then connect these up like so. I can click Auto Arrange to make this a little bit neater. And you can see now the character animate action will still return to idle after, and the worm will be removed on a separate timer. We can do something similar for when we use the tree on the worm. In our animator controller, we have this new brain take mid animation. So I'll just copy the name once again. And this time we'll go to our tree worm interaction. And I'll be a bit lazy with this one. I'll just add a character animate action at the very end. We can see that the worm now appears in the tree, but it's a little bit hard to spot, so I think what I'll do is I'll just go back into the scene window and move the worm a little off to the side. Now that we've got our character able to put a worm on this tree, let's have it so that when we right-click to examine, we get a different response. We can do this with the use of variables, and variables allow us to keep track of things like the player's progress throughout the game. Most variables we can access from our AC Game Editor's Variables Manager, and here we have a set of global and local variables. Global variables are game-wide and can be accessed from anywhere in our game, while local variables are specific to the open scene. We already have a global variable defined, input rebindings, and this was created by the New Game Wizard as part of the input system integration. Since we're dealing with the worm here in this scene, we're going to make a local variable, so I'll click on the Local tab and then Create New Local Variable. I'm going to name this variable has placed worm, and it'll be of the type Boolean with an initial value of false. For more complex data keeping, we can also use strings, integers, floats, and so on. But in this case, we only need a Boolean. We'll want this value to be set to true once we use the worm on the tree. So I'll go back to my tree worm action list, and down at the bottom, I'll add a new action, and this one's going to be a variable set action. The source is going to be local, has placed worm is the variable, and we'll be setting the new value to true. We'll want to have a different response when we examine this tree, and we can do that by editing our examine action list. Right now, this is just a single dialog play speech, but based on this variable value, we want different speech to possibly play. So in some empty space, I'm going to click Add New Action, and this one is going to be a variable check action. Again, our source is going to be local, and we'll be checking if the has placed worm is equal to true. With this action type, you can see we have two sockets, one for the condition being met and one for it being not met. We can set this action to be the front of the action list by clicking the cog icon and then move to front. And we'll have the existing speech action only play if this variable check is not met. If the condition is met, that means that we have placed the worm. So I'll drag out a socket to run a different dialog play speech action. And this time he'll say maybe that worm sure likes that tree. We have show real-time values checked in our variables manager, and that means that we can keep an eye on what this variable's value is while we play the game. I can click on the worm here, examine the tree, and if we drop the worm on, you'll see that the value changes to true, and we get a different examine response. You can see that in our variable actions, the source fields have a component option, and this refers to the variable's component that we can separately attach to game objects. We can see this in the scene manager with the variables logic button, and this allows us to add variables to a specific game object. An important part of any adventure game is the ability for the player to save their progress and come back to their game at a later time. Adventure Creator has its own save game system, and we can show this off as part of the default interface. First though, we will need to make sure that any of our scenes are listed in the build settings. If we now run the scene, we can access the pause menu by pressing escape or by clicking down at the menu button here. And from here we can access our save and load menus. When creating a game, it's important to be aware of the kind of data that Adventure Creator will save automatically and the data that we need to inform Adventure Creator manually that needs saving. To demonstrate this, we can save our game as we go through each of the interactions we've made. So if I stand in the middle about here, I can go to Save and create a new save game. Then pick up the worm and save again. And finally, with the worm in our inventory, I can use him on the tree and then save once more. If we now load up our first save, you can see our player character is in the correct position, and Adventure Creator will always save the state of the player automatically. You can see that the worm is missing from the tree, but the worm on the ground is still missing. Similarly, if we load up the second save, we have our player in the correct direction, and the worm is in our inventory. And with the third, our worm is no longer in the inventory, but is now visible on the tree again. The visibility state of the worm on the tree here is being saved automatically, and that's because we attached the Remember Visibility component to the sprite. Adventure Creator uses this Remember system as a way of telling AC what kind of data we need saving for our scene objects. For the worm on the ground here, rather than hiding the sprite with object visibility, we're just removing the object from the scene. And so in order to save that data, we need to add a different Remember component, and we can find that in the component menu by choosing Adventure Creator, Save System, Remember Transform, and on that checking Save Scene Presence. We'll then get a little warning box telling us that if the object is being removed at runtime, we'll need to make sure that the scene file is always being reloaded when we load a save game. We can do that by going to the Settings Manager and down at the bottom, underneath the Scene Loading panel, we can check Always Reload Scene when loading a save file, and that help box will have been changed to reflect that. I'll save the scene, go back into play mode, and because we've changed the way that data is being saved, we'll need to make those save games again. And if we now load back between them, we can see that the worm is now on the ground as they should be. There is a slight issue with the camera, as you can see here though, and that's just a case of telling AC that we need to record the active camera. We'll actually get a message about this in the console. If we scroll up a little bit, we've got this message that was being logged. The game object navcam1 was not saved because it does not have a constant ID script. So if we click on our navcam1, we can scroll down to the bottom and add the component Save System Constant ID. A constant ID component is just a remember component that saves a reference to the object rather than any specific data about it. This might all sound a little bit complicated, but I'm really just explaining the principles here. And in fact, we can automate this process, as I can demonstrate by removing this again and saving the scene. If we go to the Settings Manager, up at the top, we have an Auto Add Save Components to Game Objects button. If I click on that, confirm, you'll see that AEC has added that component back on for us. And essentially it's gone through our project and tried to make good guesses about what kind of components need to be added to our game to have the save system just work automatically for us. So if we now try this little test again, we can now load back between all of our saves and their states will be recorded correctly. You can also see that our variables are being updated automatically as well. Essentially, the rule is that Adventure Creator will always automatically save data that it knows that it needs to, whereas for scene objects, we'll need to tell it specifically what kind of data needs saving. Another key aspect of adventure games is the ability to play speech audio when our characters speak, as well as have any text in the game be able to be translated. Both of these things can be done in Adventure Creator, but we first need to gather up our game's text so that AC knows what text is in our game. We can do this from the Speech Manager, and down at the very bottom, inside the Game Text panel, we have a Gather Text button. You can see just above it, it says it's currently gathered 0 lines of text. So if we click this button, it will search through all of the scenes that are in our build settings. We've added our scene to the build settings in an earlier step, so I can click OK, and after a moment it'll tell us that we now have 59 total entries. This will then give us more underneath the Game Text panel. We'll now have options to filter this text by, and so we're able to see this line that occurs when we examine the worm in our inventory. Within this box we have details of what the text is, who speaks it, and we also have an audio path and file name. By default, speech audio is gathered from resources files. So if we have an audio file named player135 placed in a resources speech folder, then this will be played automatically as the character speaks this line. Resources are just asset folders, so we could create a folder named resources. Within this folder, speech, and place our asset files in here. If we scroll up a little bit to speech audio, we can see that we have a reference speech files field that right now is set to by naming convention. And this means that it'll look for specific files within resources. We could change this to by direct reference to be able to assign audio clips directly in the Speech Manager. If we have the addressables package installed, we could also set this to by addressable and have our speech be referenced by key. The Speech Manager also features a languages panel. If we then click on Create New Translation and give this new language the name, for example, French, you can see that our selected line text now has a French text box where we could either type in the translation directly or use the Export Text button to export a CSV file that we can give to translators and then re-import that from the Import Text button. We can also create a script sheet that will generate an HTML for each character. Besides speech, we also have translations for other text types, for example, menu element. We have all of our UI fields, such as pause and resume. And if we have Unity's localization package installed, we'll also have an option to link each line to a localization cell. On the subject of audio, we can also play sound effects and music. If we go into an action list here and right click, I'll create a new action and this will be sound. And you can see we have options for play ambience, play music, and just playing regular sound effects. Let's take things a little further now and add an NPC that we can talk to over here in the other side of the scene. We'll take another sprite that we can get from the 2D demo. We've got a bird character in there somewhere that already has some idle and talking animations that we can make use of. Inside 2D demo, graphics, sprites, and then bird, we've got some bird anims sprites, and we'll say maybe take this one here. So I'll take bird anims 1.4 and put him down. The exact sprite we use doesn't really matter because we'll be overriding it with animation at runtime. But I'll place this bird into the scene and then back up at the top, we're going to open up the character wizard to again convert them to a character. This time we're going to be generating an NPC, and this bird sprite is going to be the base game object. I'll just rename the character to the more simple bird, and this time, just to show the difference, we're going to go with the Sprites Unity Complex animation engine. As before, we could check auto add animator states, but this is better used for when we have a full suite of animations, for example walking and running, whereas we're only going to be changing between idle and talk for this character, so I'll leave this unchecked. But I will check add collision so that we can have the nav mesh react dynamically to them. Choosing create, we then get our bird NPC put into the center of the scene, so I'll move them back over, and you can see we've got a NPC component as well as this yellow box collider for their hotspot. Their hotspot is actually placed on a child object, the same as the sprite here. So I'll just reduce the height of this collider so that it's a bit more accurate around the sprite. If we return to the root for a moment, you can see we've got a circle collider and a rigid body. These are set up because we had the character wizard set up collision for this character, and I'm going to tweak this a little bit further because we're not going to rely on physics, but we are going to rely on the collider to carve out a hole in our nav mesh at runtime. So what I'll do is remove the rigid body and maybe reduce the radius of the circle collider a little bit. And then if we go to our nav mesh, which is default nav mesh in the hierarchy, and you can see we've got this character evasion setting, which by default is set to only stationary characters. And what this means is if a character like this bird is standing still, then the nav mesh will automatically create a hole the same size as their circle collider if the player wants to move around them. And although our player character doesn't have a rigid body, so isn't bound by physics, I'll just check is trigger in this collider just to be on the safe side. As with all other sprites in our scene, I'll select the sprite renderer for this bird and just make sure that the sprite sort point is set to pivot. Noting that the pivot point is around the bottom center, just as it is with our character and our tree sprites. To have a look at what Sprites Unity Complex does, we can go back to the NPC component, and you can see we have a section now for mechanim parameters. And these are a set of parameters that will change dynamically based on what the character is doing. So for example, we have a move speed float parameter called speed, and this will be set by Adventure Creator at runtime to whatever the character's speed is. The only change we're going to make to the character's animation is have them play a talking animation when they speak. So what we'll do is we'll just get rid of all of these, except for the talk bool, which will be set to true whenever they speak. And you can see this is named isTalking. So I'll copy this and start making some assets for them. So in the AC2D primer folder, I'll make a new folder named bird. Drop this into the folder so it's a prefab, and I'll also create a new animation animator controller. And then if I open up the bird prefab, I'll drop this animator controller into the controller field. If I then double click to open up this controller, remembering that the only parameter we have is this isTalking bool, I'll go and create that on the left here. And so Adventure Creator will set this automatically when they start speaking. We have some animations we can play. We're only going to be facing left as a direction, so we don't need to worry about which direction they face. What I'll do is I'll drop in the bird idle and the bird talk animation states. We'll use this isTalking bool to transition between the two of them. So I'll right click on the bird idle, choose make transition and drop it on bird talk. And I'll do the same in reverse. So for bird idle to bird talk, I'll uncheck has exit time so that it plays instantly, and I'll set the condition as is talking to true, and I'll also expand the settings here and clear the transition duration. For the reverse, I'll do the same thing, unchecking has exit time, clearing the transition duration, only this time the condition will set as is talking is false. Going back to the bird in the scene, we can find their hotspot on their sprite. So if we go down and create a new use interaction, we want to indicate that clicking on this bird is going to have us talk to them. So I'll set the cursor icon field to talk to. I'll set the player action to walk to, and also check face after moving. I'll click the plus icon to create a new interaction action list. And if I bring up the action list editor for it, the first action I'll do is have the camera zoom in to a dedicated camera that's positioned maybe about here, so that we can better focus on both characters. To do this, we'll use a camera switch action. And you can see we have a new camera field that accepts a camera. So we can create that in the scene manager. I can create a new standard camera type. And again, making sure that the Z position is pulled back from the same plane as the scene. And then I'll move it over to the side here and maybe zoom in a little bit by reducing the orthographic scale. We can preview this by checking the camera component, but this will be disabled at runtime so that the main camera is the only one that's rendering. I'll name this bird cam and maybe move it up to the top with my other nav cam. And then back in our action list, I can set this camera switch to have the bird cam kick in. We can have it transition over time, so maybe say 1.5 seconds, and I'll set the move method to smooth. And then while this is going on, we'll have a dialogue play speech action in which the speaker is our bird, and the line text is, "Hey, how's it going?" A key staple of any adventure game is to present the player with a list of dialogue options, and we can do that with Adventure Creator's conversation object. As the next action, we can add a dialogue start conversation action, and you can see that this takes a conversation object. Just as with the camera, this is something we can add from the scene manager, and this is underneath the logic panel. So I can click on conversation, and I'll name this bird conversation. And if we have a look at its inspector, you can see we've got this conversation component that has a section for dialogue options. Let's create 3 new dialogue options, and selecting each one of them brings up the properties of that option underneath. The first of these properties is always the label, which will appear in the conversation menu at runtime. So I'll set the first to wow, a talking bird. The second, maybe what are you doing here? And the third will be an exit option. So we'll say, got to fly. We can ignore most of these other options, but to make the conversation feel a little bit dynamic, what we'll do is we'll have this second option hidden by default, and then only show it after we've played the first one. So if we select this middle option here, I'll uncheck is enabled. And now we can go back to our start conversation action, and I'll drag this bird conversation into the conversation field. Conversations will normally run their own action lists, and that's what this dialogue option field refers to. But it's actually a lot easier just to check override options, and we can then dictate exactly what happens within this same action list. So if I expand this, I can now drag out wires for each dialogue option and create new chains of actions. So for the first option, for each option, I'll just have the player say what was displayed on screen. Actually, I'll move these out the way for a moment. Follow this up with a line from the bird. Maybe he says, adventure games are weird. We'll also make it so that choosing the first option enables the second. So we can do that with a dialogue toggle option action. The conversation will be bird conversation, and we'll set the second option to on. We can then return back to this conversation just by rerouting this action chain back onto the action. For the second option, again, I'll have our player character say the option that was displayed. And we'll just have the bird say something else, maybe just enjoying the view. Again, returning to the conversation. And for the last, we'll have our player say, gotta fly. Followed by the bird saying, you and me both. We can stop the conversation just by stopping the action list, but we'll also make sure that the camera is returned back to our regular nav cam. So we'll add another camera switch action. Now we could select our new camera manually as navcam 1, but we can also just check return to last gameplay. Again, I'll have a transition time of 1.5 and set the movement to smooth. We can tidy up all these actions by clicking auto arrange, and let's now see how this all plays. You might have seen that we've got My New Player appearing in the subtitles box whenever our player speaks. I think I'll just make a quick correction to that. So if we go to our player prefab, you can see in the inspector, underneath the player component, we've got this dialog box, where I'll just rename the speaker label to the character's true name, which is Brain. It's also worth mentioning that with the bird NPC here, we've made this character a prefab and then updated the scene instance with some interactions that are present in the scene. And this is because interactions and other scene-based action lists cannot exist in prefabs. And this means if we were to drop this action list into the bird hierarchy and update the prefab, it wouldn't then transfer properly if we were to drop the bird into another scene. We can get around this, however. If we wanted to have the bird be in multiple scenes and have the same interaction run each time, we can just change the hotspot's interaction source to asset file, and you can see our interaction fields then change to the type action list asset, which is similar to these scene-based action lists, only it exists within our project. Well, that's about it for this tutorial. It wasn't completely comprehensive. Adventure Creator does have a lot of features, but this was more of a quick start guide to help you get up and running as quickly as possible. One of the key features that we haven't covered here is the ability to use parameters within action lists to let you recycle them for different purposes. We can find tutorials for this and more on the tutorial website, which we can access by going to the top toolbar and choosing Adventure Creator, Online Resources, and then Tutorials.